Okay then guys, just a few things to say before you have a go at this section, just to make it as easy as possible really, and straightforward. These are the sorts of curves we're going to typically draw in this section. Straight lines are what we should have done or be familiar with anyways, but basically m is the gradient and c is the intercept. So for example, if you have 2x plus 3, y equals, well, you can mark off the intercept on the axes, and then we can draw a straight line of gradient 2, so it'll be quite steep, won't it? So that's not really steep enough, is it? That's quite shallow. So when you're sketching this sort of curve, bear that in mind. You can always change the scale. That's gradient 2. A flat line is 0 gradient, of course, and then a downwards line is a negative gradient, isn't it? And we always read from these lines from left to right. So this is the forwards facing positive direction. So there's an example there of that one. Quadratics, so they're all much of a muchness. M is just a gradient, which you read off. C is the intercept, which you read off. It's where it hits the y-axis there. So that's basically straight lines then, in a nutshell. Quadratics, basically you look at a quadratic, it's either going to be a U-shaped curve or an N-shaped curve. If it has roots, then you'll know that an A is positive, then you'll be able to find the roots by factorization or using the formula. And you can draw the U-shaped curve that's provided that A is greater than 0. If A is less than 0 and it has roots, it's going to look like so. Anywhere along here if it has roots. But and you can find these roots either by factorization or by completing the square. If it doesn't have roots, then the best way to do it is to complete the square rather. So factorization or using the formula to get the roots. If it doesn't have roots, you complete the square, and typically if it doesn't have roots, it'll be something along these lines down here or here. So that's the sort of a range possibilities that you get. So if A is positive in this standard form here, then you're going to be drawing a U-shaped curve somewhere on the plot. And if A is negative, then you're going to be drawing an N-shaped curve somewhere. And if it has roots, you can mark them off and draw the curve. So that's essentially all there is to quadratics then. Let's have a little look at cubics now. You've got a cubic of this form in general. Basically, if A is positive, then for large x, this term dominates. So large x and A is positive. It means the values will shoot up positive. And for large x negative, this term dominates. So a large term cubed will still be minus, won't it, if it's negative large. And you'll get an extremely large negative term. So it's going to come up, cut through, down and back up. Now that's typically the shape you're going to get for A positive. Now if it doesn't have roots, it will have one root, but this top bit here may not just break the x-axis. It might come down and go back up. So it's always going to have one solution here, like so. But this sometimes may cross it, and also sometimes these roots can meet at the same point. So as with y equals x cubed, it goes through here, doesn't it? And then it turns and goes back up. So there may be, all those roots may coincide, be coincident there. So that's what it is when A is positive. When A is negative, it just flips the other way around. So instead of going up and up, it goes down, up and down. There we are. And again, you can get at most 3 roots. You're always going to get 1 root, and this is if A is negative. So that's the wherewithal with cubics as well. So that's all there is. There might be 1 or 2 quartics, power 4 polynomials in the sketch, but essentially you follow the same process to draw those as well. So all the best in this section then, guys, and I'll catch you in the next one. Cheers!